guys, today we're going to do the review over Unit 9, which was additional trigonometry topics. There is three main things that we're going to do. So law of cosines, law of sines, and then everything that had to do with vectors. Okay, so let's start at the beginning. For the law of sines, so solve for the missing measure using law of sines. So here in the review, I am being a little nice and I put in the directions that you're going to use law of sines. On the test, it doesn't tell you which one to use. So you need to be able to figure out which one to use on your own. So my suggestion for law of sines anyway, is you're looking for angle and opposite side. So for example, let me zoom in to number 1 closer. They want us to find BC. So they want us to find side A, if you think about it, because if this is big A, this would be little a, and there's my BC. So what we're looking for is opposite angle, opposite side. So this is what I mean. We have angle A, that's 39, and we're looking for its opposite side. So that's one pair, but you also need a second pair. So looking at this, I have this side, so I have this side, but I don't have the angle that goes with it. But that is a pretty easy fix. Triangles are 180 degrees, so I just need to subtract from 180 to get what goes here. So I do have a calculator already. Let's do this. 180 minus 51 minus 39. So that is actually a right triangle. That's going to be 90 degrees. Okay, so I have my two sets of opposite angle and side. So let's set this up. So it's called law of sines for a reason, because you are going to use sine. So let's do sine of 39 degrees. And I am getting that from right here. That's A. When I go opposite, I labeled that side A. We don't know what that is yet, so we're just going to put little a equals now the other pair. So sine 90 over 27. All right. Now we're going to cross multiply. So I'm talking about kind of like an X like that. So that will give us A sine 90 is equal to 27 sine 39. And then I am trying to solve for A, so I need A to be all by itself. So we are going to divide both sides by sine 90. That way it can cancel out from the left. So A is going to equal whatever that expression ends up being. So now back to my calculator. Let me move it over to this side. We're going to type in this expression here. So I need my fraction, 27 sine 39 over sine of 90. All right, so 16.99. I'm going to go ahead and round that to just 17. So find BC. It is 17 units long. Okay, let's look at example number 2. If the measure of angle B is 45 degrees, BC is 28, and AC is 27, find the measure of angle A. So notice they didn't give us a picture of a triangle here. We're going to have to do this on our own. So obviously it's not going to be to scale because we can't really draw the triangle unless we know all the measurements, which we don't. So we're just going to try our best. I'm going to go off of this fact right here that B is 45. 90 is a right angle, so 45 is going to be about half of that. So I'm going to say that's 45. So let's let that be B. It's a triangle, so I'm going to connect these two sides and let's label A and C. So we know that B is 45. Cool. What else did we know? BC is 28, so BC is at the bottom. And AC is 27, so that's the right side for me. They want us to find the measure of angle A. This angle here. So good thing, law of sines, I need opposite angle and sides. I already have that here. So since I'm solving for angle A, I'm going to start writing my proportions with that. So sine of A over Now I go to its opposite side, 28 is equal to sine of 45 degrees. I go to that one's opposite side, and that's 27. So just as before, we're going to cross multiply. So first I'm going to cross multiply this way. So that'll be 27 sine A is equal to, and now cross multiply the other way, 28 sine 45. We want A to be by itself, so let's divide both sides by 27, right? So it'll cancel from here, and I now have this fraction. The problem is that when I look at what's left over, it's sine A, and I just want capital A by itself. So now I want to move sine over to the other side of the equal sign. When I do that, it's going to turn into sine inverse. So A equals sine inverse of that entire thing that we have written. I'm going to rewrite it. So 28 sine 45 over 27. Okay, so calculator problem. We just got to type this in and see what we get. Sine inverse 28 sine 45 over 27. Okay, so 47.2. Let's round that. 47.2. degrees. All right. So that's law of sines, finding a side length and finding an angle measure. So now let's look at law of cosines. So again, I was nice, and here in the review, I'm telling you that these are law of cosines. On the test, I don't tell you. So what do you look for when you need to use law of cosines? Well, two different situations. Side, angle, side. So that's this first one, side, angle, side. Or if you have all three sides, side, side, side. Those are the two different times that you're going to use law of cosines. Okay, so let's look at our first one. Find AB. So AB is this side right here, AB. But since it's opposite from the C, I'm going to label this as little c. Law of cosines is a little bit more complicated than law of sines. Ideally, remember, you're going to have your notes to look at, so you could just get the formula from there, but luckily I have it memorized, so I'm going to write it down for us. It's little c squared is equal to little a squared plus little b squared minus 2 times a times b times cosine of capital C. Now, the way that this triangle is set up, I have my little c labeled. You can see that. But I'm going to go ahead and label the other sides. So if this is capital A, then this 22 must be little a, which makes this 20 little b. So now let's just fill in what we got. We don't have little c yet. That's actually what we're looking for. But little a is 22 plus 20 squared minus 2 times 22 times 20 times the cosine of capital C. Capital C is 95 degrees. Okay, so I know it looks long and complicated, and it is, but let's just put this into the calculator. So this entire right side, 22 squared plus 20 squared minus 2 times 22 times 20 times cosine of 95. So big number, 960.7, let's say. But that's for c squared. I want it to just be regular c. So in order to get rid of that squared, we're going to square root both sides. So c is equal to, so here in Desmos, there's a button that says answer. So I'm going to do square root of answer, and that just gets the previous number. So that would be 30.99. Let's just call that 31, right? 31. All right, so that's when you're looking for a side length. Finding an angle with the law of cosines is a little bit more complicated. Oops, what did I just do? There we go. Okay, so find the measure of angle A, and there's our triangle with all three sides labeled. I am specifically looking for angle A. Let's label the sides. So if this is capital A, then that 10 must be little a. 17 must be little b. 11 must be little c. So I'm looking for capital A, so I need the law of cosines that has capital A in it. So again, I know this formula, so I'm going to go ahead and write it for us. It says little a squared is equal to b squared plus c squared minus 2 times b times c times cosine of capital A. So we have a choice. Either we can plug in our numbers now and then rearrange everything, or I can rearrange it first and then plug in numbers. And I think it's going to be easier to rearrange it with letters first, and then we can plug in our numbers. So remember, I want to solve for capital A. So I need to find a way of getting capital A all by itself. So first thing I'm going to do is subtract these two things from both sides. So it'll cancel, and I'm left with a squared minus b squared minus c squared is equal to negative 2bc cosine A. Okay, but now this negative 2b and c, they're all multiplying, so in order to move them over, I'm going to divide. And they cancel. And last thing that I have left is that cosine. But we know that when we move it over to the other side of the equal sign, it's going to become an inverse. So I'm going to do that. I'm going to make it become an inverse. But I'm also going to switch the sides of this equation. So capital A is equal to cosine inverse of a squared minus b squared minus c squared over negative 2bc. Okay, well now I'm going to fill in my numbers. So we have A was 10, so 10 squared minus 17 squared minus 11 squared over negative 2 times 17 times 11. So I'm going to type in that whole thing into the calculator and let's see what we get. Okay, so there it is, 34.01, so just 34 is fine. Angle A is 34 degrees. So that is law of cosines. Law of sines, law of cosines. Formulas are in your notes, so you should be fine. Right, next thing is finding areas of triangles. So we know the basic formula for area of a triangle is 1/2 base times height. The problem is these triangles are not going to give you the height. So we have to use those other formulas that we came up with. So when you have a triangle like this one, so this one is a side angle side triangle. Side angle side. Because, I mean, if you look at it, there's my side, here's my second side, and I have the angle in between. So what I'm going to do is use this formula. Let me write it. So A equals 1/2 A times C times sine of B. So really what you should see every single time is you'll have two sides and the angle between them. So these letters are always going to be different from this one. But now we're going to plug in what we have. That 17 is little a, that 30 is little c. Okay, 1/2 times 17 times 30 times the sine of capital B, so sine of 88. So this is really easy. You just have to put this into the calculator. Okay, so 254.8. So the area of that triangle is 254.8 square inches. See how they're measuring in inches? Okay, the next one, so number 6, it's still area. I want to find the area of that triangle. But this time I don't have any of the angles. All I have is all 3 sides. So in this case, when you have side, 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 this is Heron's formula. So area equals, it's a giant square root, S times S minus A, S minus B, S minus C. So A, B, and C come from the 3 sides. I know this triangle is labeled RST, but it doesn't matter. A, B, C are the 3 sides. S is the semi-perimeter. So let's find S first. For semi-perimeter, it's 1/2 of adding up all the sides. So 10 plus 10 plus 15. So S equals, well, let's see. 17.5. And now I can plug it into this formula here. So area, I'm going to write this on the bottom because I think I need the space, is 17.5 times 17.5 minus 10. That's this side. 17.5 minus 10 again, so that's for the bottom side. And 17.5 minus 15. That's for this side here. So that whole entire thing needs to go into the calculator. This one. All right. Square root 17.5. Okay, and this is what I get, 49.6. So the area of that triangle, sorry, this is getting a little messy, I'm right here, is 49.6 square miles. Okay, so that's all the stuff with triangles. So law of sines, law of cosines, area. The rest of this review is going to deal with vectors. Okay, so first thing about vectors is to find their magnitude. Remember, magnitude is just another fancy word for length. So if you were to draw the vector, how long would it be? So the first one they give us is the vector RS, where R is at the point -3, 9, and S is at the point 8, -1. So if this is x1, y1, and this is x2, y2, we use the formula. So magnitude of RS we subtract the x's. So 8 minus -3 squared plus we subtract the y's. -1 minus 9 squared. Now, just the way that these work out most of the time, sometimes they're perfect squares, sometimes they're not. I like to do just the inside first. So that's what I'm going to do. Let's do the inside. 8 minus -3 squared plus -1 minus 9 squared. So that's 221. Okay, now is 221 a perfect square? I honestly don't know, so let's check. No, it is not. So we can check to see if we can simplify 221. You can't divide by 2, can't divide by 3. Honestly, I'm just checking. I don't know my multiplication. It's 13 times 17, and those are two primes. So it's actually not going to simplify. This is a kind of a weird case. So the magnitude of RS is equal to the square root of 221. All right, so let's look at the other one. This is the one that we're used to seeing most of the time, vector C in component form, 5, -3. So remember, this in component form, we have to assume that it starts at 0, 0. So when we write this out, and we do our square root, we have no x's to subtract. Like it's usually x2 minus x1. There is no other x. So we only stay with that 5. So 5 squared plus, and then same thing here. There's no other y's to subtract. So -3 squared. And let's see what we get. So I'm going to do just the inside. So that's 34. I know that's not a perfect square. Let's double check though. Yeah, it's not. So it is even. So I'm going to do this to the side. Let's see if we can simplify this. 34 is 2 times 17. Yeah, and 17 is prime. So again, usually this doesn't happen, but I can't simplify that radical. It's going to stay the way it is. So the magnitude of C is the square root of 34. All right, so let's look at some more stuff. So the next thing we're going to do is find a unit vector in the same direction of the given vector. So remember, unit vectors have a magnitude of 1. Like that's the whole definition of a unit vector. It is only 1 unit long. These vectors that you see in front of you, they're going to be longer than 1. So how do I shrink them down to where they're only 1 unit long? So there is a formula for this. I'm going to use the letter U to represent unit vector. Is you take your regular vector, so I'm going to use the letter V, and you divide it by its magnitude. So that we need to find the magnitude first. Once we have that number, we just divide by that number. So let's look at this, P. Well, like I said, we need to find magnitude, so let's do that first. Magnitude of P, -12 squared plus 9 squared. Okay. I'm going to do just the inside. $225. What's the square root of 225? Ooh, perfect. It's 15. So this is one of those nice ones where we have a whole number. Okay, so now what we're going to do for our unit vector is we're going to get P, so -12, 9, and we're going to divide it by its magnitude, 15. So this would be -12 over 15, comma, 9 over 15. Like all I did was divide each one by 15. But these can be simplified, and if at all possible, you're always going to want to simplify, so let's do that. -12 over 15, they're both divisible by 3, so I know that's going to get smaller. Let's see. I'm cheating a little bit. So if you type it in and then press this button, it simplifies for you, so -4/5. And what was the other one? 9 over 15. So that's 3/5. Okay, so there's my unit vector. It's going in the same direction as the original one. It's just, it got shrunk down to where it's only 1 unit long. Let's do one more like that. So this is vector S. Let's find its magnitude. So I'm going to start with the inside of that radical. 9 squared plus 3 squared. Oh. There we go. 90. Now 90 is not a perfect square. I'll show you. See, gives me decimal. So I'm going to have to leave it in radical form. But can I simplify this? Well, I'm going to do that to the side. 90 is 9 times 10. That 9 is 3 times 3. 2 times 5. So there's 2 3s. That can go to the outside. So this is going to become 3 square root 10. Okay, now we're going to get our vector. So 9, 3. And we're going to divide it by 3 square roots of 10. Okay, so 9 divided by 3, we know that's 3, but you're still going to have that square root of 10. So 3 over square root of 10. And then for the y component, 3 divided by 3 is 1, but we still have square root of 10 at the bottom. Okay, so this is where I'm at right now. But we already know we're not allowed to have radicals at the bottom, so we need to simplify that. We need to rationalize. I'm not going to show my work. I'll just give you the answer. But basically, we're just going to multiply the numerator and the denominator by square root 10. So this would become 3 square roots of 10 over regular 10, and square root of 10 over regular 10. Okay, for the next two, we're talking about trigonometric form. So for number 11, it says find the component form of the vector with the given magnitude and direction angle. So they want us to go all the way down to component form, but we have to go through trigonometric form first. So I know we don't remember, but I'll give it to you. Trigonometric form would be magnitude, cosine, theta, and then magnitude, sine, theta. So if you look at this, they gave us magnitude and they gave us theta. Like they gave us exactly what we needed to write it in trigonometric form. So let's start there. W is equal to 8 cosine 60, 8 sine 60. All right, but cosine 60 has an actual value. Like I can look that up on the unit circle and figure out what that is. So that's actually exactly what I'm going to do. Sorry, I don't have it pulled up yet, so let me grab that really quick. Okay, so we're looking for cosine of 60. So here's my 60. Cosine is 1/2. So 8 times 1/2, comma 8. Well, now I want sine of 60. So 60, sine is square root of 3 over 2. Okay. 8 times 1/2, that's just 4. And then over here, I have 8 divided by 2, that is 4, but I still have that square root of 3, so 4 square roots of 3. And that's component form, so there's no longer any sine or cosine in there. We got actual numerical values. Okay, but what about going backwards? What if I have component form and I want to change it into trig form. Well, there's two things I need. We already talked about. I need the magnitude and I need the angle. Magnitude, we've already done this a bunch of times, so that's pretty easy to find. (15 squared plus 8 squared). So let's put this in the calculator so we can see what we get. I'm not sure if that's a perfect square. Let's see. Oh, it is 17. So we got lucky. Magnitude is 17. Cool. Now I want to find theta. So I want to find the angle of this vector. This is in your notes, but the formula is tan inverse of y over x. So for this, 8 over 15. Okay, so let's put that in the calculator and let's see what we get. (28.1), let's say, because 0.7 rounds to 1. 28.1. Okay, so I have magnitude, I have direction. I can write this in trigonometric form. So h is equal to 17 cosine of 28.1, comma, 17 sine of 28.1. Okay, and then the last thing that I wanted to show you guys, this is just what we did yesterday, but finding the angle between two vectors. So this one also has kind of a long, complicated formula. So you need to know the dot product. So let's do this actually. Cosine theta is equal to the dot product. So since this one is dealing with vectors a and b, I'm going to write it with a and b, over the product of their magnitudes. So it's kind of a lot to work with, but don't worry. It's pretty much you set it up and then put it in the calculator and you're fine. I'm going to want to solve for theta. So eventually I'm going to have to move cosine over. So instead of doing it that way, I think I'm going to go ahead and move it over now, just so that I don't get confused later. Right, like that. Okay, so let's see. So theta equals cosine inverse. Let's start with the dot product. You do corresponding parts. So -2 times -9 plus 1 times -4. Okay, then I need to find the magnitude of each vector. Magnitude is the one with the square root. So magnitude of A, I'm just looking at A right now, is square root of -2 squared plus 1 squared, and then times magnitude of B, -9 squared plus -4 squared. So you have a choice. You could type in the whole thing exactly as you see it now. It is kind of a lot to type, but if you're careful, you should be fine. Or you can simplify it first before you type it in. For the sake of time, I'm just going to type it in the way I see it now. Okay, so let's make this a little bit smaller so I can see it while my calculator is up. Okay. Cosine inverse. -2 times 9 plus 1 times -4. Okay, so that's the numerator. Okay, denominator, square root of -2 squared plus 1 squared times, okay, next square root, -9 squared plus -4 squared. All right, so you see what I did. I had to type pretty much very, very slow. I'm just going to double check that everything looks the way I wrote it. -2 plus. Yeah, I think that's it. So that's going to be our answer. Theta is going to be 177.4 degrees. All right, let's look at the next one. So just one more example so we can practice. This one is given to us as a linear combination, but it's really the same idea here. So we're going to do theta equals cosine inverse of. So we need to start by getting their dot product. Look at the coefficients. So that's 1 times 6 plus 8 times -6 over. Now we need to get the magnitude of each one. This one is going to be 1 squared plus 8 squared times, over here, 6 squared times -6 squared. Okay, and just like we did before, I'm going to type in that whole thing into the calculator. Okay, 1 times 6 plus 8 times -6. Square root 1 squared plus 8 squared times square root 6 squared plus -6 squared. All right, and that's what I get for that one, 127.9. 127.9 degrees. Alrighty, guys. So that's everything that's going to be on the test. Now, I did want to save a little bit of time, so there is a dot product question on the test, but that's just a numerator of right here. So I didn't put any examples in the review, but it should be super easy. There are some where you have to add and subtract vectors as well, but again, that's so easy that I didn't think I need to review it. So just make sure that you have your notes handy as well at the same time as taking the test, and you guys should be fine. Let me know if you have any questions. Bye.